Hi, my name is Wolfgang, and today I'm teaching you how to do math. I think, maybe, depending on what you're doing today. Today's a very important lesson if you're in high school or college, depending. Today, talking about derivatives. I hope this helps. Hope you're able to see this, but derivatives is kind of a weird little talking point. I would say, depending on like what kind of derivative you're talking about. But anyway, if you don't know what a derivative is, it's the instantaneous change of a rate of a function at a given point, or instantaneous velocity of an object at x equals a. Required is for all. It's kind of required for you to learn. So, rate of change at x equals a. So what does rate of change mean? It's more just like at what rate in a line. Let's say we'll do a parabola here. Like, what is the rate of change at this point? What would you say? Usually it's not the simplest. You also say it's the tangent, or let me draw that correctly. The tangent of a line at that point specifically is kind of like the x at a, thus combining those two. But how do you even think about that? How does one compute rate of change? There's a lot of rules you can do. There's a lot of instances where you might have to use it. However, I think I'll just visit the limit rule. The limit rule is the instance where if you find to have the derivative of a function f, you have to use the limit of h at 0. H, in better words, h equals small increments of change at x. However, a lot of people don't really know that, nor do people really find it helpful to have it where the equation for change of x makes it even better for them. It's a lot to draw or write in general, and sometimes people just kind of forget that that change of x is not equal to x. People forget this sometimes. I want to make sure. I want to make sure that people know this and that h is a replacement of this. So keep in mind. And so basically, you get this now. You get a little line here. Fx plus h plus fx over h. Why is this important? Why is this important? Honestly, when I was learning it, I didn't really know. But it's to make sure that there is a change in the original function that you can subtract with this. I just realized this is not a plus, this is a plus sign. If I remember correctly, it is a minus sign. It is a minus sign, so forget that one. This is a minus right here. Forget a plus here. All right, why is the limit at 0? Why is it at 0? Honestly, this is up to you. I thought it was basically because it's calculating a rate of change at 0. But however, it's calculating rate of change when the change is 0. Will you remember this later? That's a very important point later. So now that you have this kind of memorized, how do we use this in an example? All right, let's teach you an example. Let's say f of x equals to 4x minus 6. Let's keep it simple, right? We're trying to find a derivative of this function. but we have no idea because we're kind of stupid here. Okay, I'm stupid. Don't worry. We're all stupid in this sense. All right, let's try to fit this formula into that example. F of x. Usually the tail derivative between from its original function and a derivative, you have this little apostrophe right here. So keep that in mind. Equals limit. It's not drawing it. There you go. Oops. H dun, dun, f of x. How do you put this h into here? It's kind of simple. Not really, but you kind of get it. 4x plus h minus 6. Why there's not h here? We're trying to calculate x plus h. And usually this doesn't have an x. And since it doesn't have an x, you don't have to worry about that. You only have to worry about this x right here. Minus 4x minus 6. To solve this, it's pretty simple. It just kind of turned this into a negative. But since 4x is a positive and negative 6, it'll turn into something else. But I'll get that into later. And then all over h. So you kind of have a general idea of what to do. So now what you do is rewrite this part. I'll keep doing that for some reason. I don't know why. To now fit into that, and then that. So you get 4x plus 4h minus 6 minus 4x plus 6. Spooky, I know. All over h. Now that you have this equation, you can subtract the top numbers from each other. So 4x minus 4x cancels out. Minus 6 plus 6 cancels out. And now at the end of it, you pretty much get 4h over h. Now here's where this comes in. H is going to 0, which kind of basically means in this scenario that h is 0. That's kind of what this is interpreting as. So you get rid of this, because now we're implementing this, putting this into this. So first you divide by h, but wait a minute, h is gone. You don't have to worry about it. So the answer of x is equal to quattro. That's kind of the basic way of doing this. This is a very easy way to solve it. I'm giving you the limit way of solving it because your math teacher will kill you if you do not know this before you head into other rules. So I hope that kind of clears up that instance of it. What are other rules in this derivative world? There's many rules. I'm not going to get into all of them because I have no time to get rid of there. Dun, 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 dun. I have no time to get into them. There are 3 rules I'll get into today though. First, product rule. Second, power rule. And then the quotient rule. Quotients rule. These two are hella hard. The power rule will help you in this case though. I'll do the power rule first to kind of give you a better insight in a sense of that. So, what is power rule? All right, I got my notes. I lost my notes. I'm fine. The power rule states that the derivative of a function where x is raised to a power of n will equal to n being brought down, or should no, n being brought down next to x, and the power changes to x minus 1. Why is this? Usually when you do it in the same limit rule that I presented earlier, it's a weird kind of thing. I'm not really too well versed into it. But all you really need to know is that n will be brought down next to x, where it'll be multiplying x, and the power in which n was here previously gets subtracted. So n remains the same, but it's multiplying x. The power n is subtracted by 1. How do you compute this? How is this possible? I don't know. I'll be real and blunt here. All right. I hope my avatar is saying away, but anyway. So now how do we do this? How do we compute using this? It's kind of not easy. Let me make it to where y'all can see it, hopefully. And doot 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 doot. All right. Let's say we get f of x equals, let's do something really easy. Let's do x to the power of 8. So we see the 8 and we immediately say this is our n number. It's our n. All right, so how do we compute that? It's pretty simple. If you know the power rule, you bring down n to x. So n minus 1. So 8x, then 8 minus 1. What would that be? You write it more better. There you go. Simple. That's your answer. But Wolfgang, that's so easy. How do you do it? Shut the fuck up, bro. I don't care. This is the easier way to do it. And that, my friends, is how you pretty much just do it. It's not that hard. If you know the power rule, I think you'd be able to solve the easier questions. When it comes to calculus, I hope that at least gives you a bit more. At least I made it more presentable for you. Product rule. The product rule is so stupid. Sometimes I get so pissed off about this. The product rule states, this is a new little thing you have to do. Okay, don't be scared. All right, it's okay. D over dx. This means derivative of something in these brackets here. Of fx if multiplied with another equation such as g of x will equal to, this gets long, derivative of f times g of x plus g of x, or derivative of g of x, excuse me, times f of x. What in the hell does this mean? This means if you have two equations multiplied together, they will be simplified into derivative of f times the regular function of g, and vice versa. And you just add them together and you get like a pretty simple way of solving for that. But how do you even memorize? How do you even put this into example? Let's write it again. D over d x of f and g. This take a minute. This takes a minute. I do apologize, but I realize I've been pretty quiet in this recording. The reason being because I'm in a dorm with thin walls, and I need to be quiet. This is ignore this. Let's get an example. Let's say f of x equal to like x3, right? And g of x is equal to let's say 2x2 plus 8. Simple, correct? So how do we simplify all of this into this formula? First, let's start with finding derivative of x3. We solved the earlier. We'll write down here actually. I'll give you a second. Correct. Ta-da. And let's do g now. But Wolfgang, you never told me what you do if the derivative has to include this. What do? Change it to 0. Why? A constant number being turned into a derivative is always going to be 0. That's a constant. That's this is what's called the constant, I believe the constant rule. Constant rule. Now that doesn't, I hope it makes sense, but in later terms, you probably understand it. All right, so that's not 0. But what do you do now? Basically, you just kind of have to get rid of it and do the product rule for this. So 4x 2 minus 1 is 1, so you get rid of that. Wait a minute. Why do you, what would you do with the 2? Why is it 2? When you bring it down, you're multiplying the number in front of x. So if we were to say x4 and we try to do the product rule, technically the number in front of x is 1. So you're multiplying 1 to just 4. So in this instance, bringing down 2, you're multiplying 2 by 2. 2 by 2 is 5. Now I'm playing 4. And then 2 minus 1 is 1. And since there's no exponent of 1, you just leave it as is, because exponent of 1 is 1. You can't really do anything with that. Or the exponent of x is going to be x because there's nothing multiplying that x itself. All right, now that we have this, now we just kind of fit that into here. Simple enough, right? So first, 3x2. 3x2 times g of x at 2x2 plus 8 plus g of x in derivative, so 4x times regular equation f, so x3. And if you're, I think you're able to, you should be able, but I'll do this for you. So 3x3 times these two numbers. So we get 6x4. 3x2 times 8 equals 24. x2. There. Simple. Now we go on to here. Plus 4x times 3, or x to the power of 3. 4x4. And then you simplify. Can you simplify here? Yes. Which ones? These two numbers. Boop, 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 boop. So you just add them together. You get 10x4 plus 24x2. And there's your answer. Okay. I'm too lazy to do quotient rule, nor am I able to do any other rule because I am tired. I want to sleep. So I hope you find this video at least some sort of helpful. I really like doing math videos because that's actually pretty fun. Derivatives is also become such a pain in the ass for me when I was doing my calculus, pre-cal, cal 1, cal 2, and in university. So if you find this interesting, at least helpful, let me know, and then I'll do whatever. And also I will be adding clicker noises in these videos to get you, yes you, pay attention to these videos because I need that retention rate. So, and I know all you are probably used to this by now. I'm not calling you out in particular, but like, all right, I'll see you.